In this video, we are going to look at GCF, or greatest common factor factoring. So GCF, as I said a minute ago, stands for greatest common factor. And remember that factors are numbers that are multiplied together to get a specific product. So for instance, we could look for all the factors of 8. The easiest way to do this is to set these up in pairs. So we could do 1 times 8 to get 8, or we could do 2 times 4. There's nothing times 3 that gives us 8, so then we're back to 4, which is already in our list. So these are our only factors of 8. 1, 2, 4, and 8. So the greatest common factor is the largest factor that 2 or more terms have in common. So for instance, if we wanted to look at 12 and 18 to find the greatest common factor, we could list the factors for both. So 1 times 12, 2 times 6, 3 times 4. The next one, if we're going in order, would be 4. Since it's already up there, we're done. So 1 times 18, 2 times 9, 3 times 6. There's nothing times 4. There's nothing times 5. And then we're back to 6, which is again already up there. So if we look, we can see that the largest number, the largest factor they both have in common is 6. So we're going to use that idea to find the GCF of 45x to the third and y. So we can start by looking at 45 by itself. So 1 times 45, can't do 2. We can do 3 times 15. 4 doesn't work. We can do 5 times 9. And then 6, 7, and 8 don't work. We're back to 9, so we're done. Now, x cubed we could write as x times x times x, and we just have one y here. So then let's go over and look at 75. So we can do 1 times 75. 2 doesn't work, but we can do 3 times 25. 4 doesn't work. We can do 5 times 15. 6 doesn't work. 7 doesn't work. 8, 9, 10, 11, and 12, 13, 14, and then we're back to 15. We can write x squared as x times x, and we can write y squared as y times y. So for the numbers, we're just looking for the largest one they have in common, which is 15. And then for the variables, we're looking for the most they have in common. So they each have 2 x's, which would be x squared. And then we can make a pair of 1 y's. So that's the most that they have in common. So our GCF is 15, and then x squared because they have 2 x's in common, and then y to the first. GCF factoring is actually the most important kind of factoring because, as you'll see later, it is what we always do first. So we're going to start by looking at 4x squared minus 8x. If I look at 4 and 8, the largest number I could divide them both by is 4. And then they have 1 x in common. 4x squared has 2, 8x has 1, so the most they have in common is 1. So I'm going to factor that out, which is division, but you can kind of think about this as undistributing. 4x squared divided by 4x would just leave me with an x, and then negative 8x divided by 4x would give me a negative 2. So the one thing you want to look for is, do my factors inside my parentheses have anything in common? They don't. And I can easily check GCF factoring by simply distributing. So if I went back and multiplied this, would I get 4x squared minus 8x and I would, so I know this is correct. Moving on to the next one, the largest thing I can divide both 9 and negative 12 by is 3. They have x to the third in common and only y squared. So again, I can't remove more x's or y's than something has. So 9 divided by 3 is 3. If I take out 3 of the 4 x's, I'm left with 1. And I'm taking out all the y's, so there's no y's left. Then I'm going to move on. Negative 12 divided by 3 is negative 4. I'm taking out all the x's, and I'm taking out 2 of the 3 y's, which means there's only 1 left. So if I look, 3x and negative 4y have nothing in common, and if I go back and I distribute, would I get the original problem that I started with? And I would, so I know my answer is correct. For the last one, I can divide both 21 and 7 by 7. And then this one has 2 x's, this has 1, so the most I can take out is 1. Now, 21x squared divided by 7x would be 3x. And now what I'm doing is negative 7x divided by 7x, which would be a negative 1. So anytime you're factoring something completely out, it always has to leave behind a 1. Because if I went back and distributed and I didn't have that 1 there, this wouldn't work. Another important thing to remember about factoring is when we have a negative leading coefficient, we always have to factor that negative out. So if I look at negative 2x plus 4, I know they're both divisible by 2, but since my leading coefficient is negative, I'm actually going to factor out a negative 2. So negative 2x divided by negative 2 is a positive x, and then 4 divided by negative 2 is a negative 2. So again, if I went back and distributed, would I get my original answer? And I would. Same thing for the next one. I have a negative leading coefficient, so instead of factoring out 3x, I need to factor out negative 3x. That will leave behind an x and a positive 6 because I have negative 18 divided by negative 3. Again, I can easily and quickly check that my answer is right using distribution, and this is my factored form here. In the last one, you'll notice that none of my terms actually have anything in common. However, I do have a negative leading coefficient, so I have to factor out at least the negative, which is just going to change the sign on everything because I'm dividing everything by a negative. So even though it looks like we didn't do much, we have to factor that negative out at the start.